This presentation is about the anatomical progression of a rhegmatogenous retinal detachment. Once you have a retinal break which is formed and you have vitreous which is degenerated and liquefied so that there is a possibility of eddy currents forming inside the vitreous cavity. So before embarking on this teaching session, I would like all of you to get familiarized with this standard diagram which is used to note down the pictorial depiction of a retinal detachment. So this is a diagram which can be used for both the eyes, either the right eye or the left eye, and you are supposed to note down the name and the date when this was noted. And these are three concentric circles which are intersected with these lines, which basically represent the clock hours in a clock face. So this innermost line represents the equator, this represents the ora serrata, and this represents the end of pars plana and start of pars plicata. There are two more diagrams. This is the horizontal cross section of an eye, and this is a vertical or a sagittal cross section of the eye. So once equipped with this information, we'll discuss the break formation and the progression of a retinal detachment. So for a retinal detachment to happen, it is very important. There are two prerequisites to happen. One is the formation of a retinal break. So we'll make a retinal break here. First we should make the optic disc and the corresponding blood vessels and the fovea or the macula. So this is as depicted, this is the right eye, and if we create a retinal break, so you can have various designs of retinal break. It can be holes, it can be flap tears. So let's create a retinal hole here, which is rather simple to understand. And so if we have a retinal hole here, rather let us place it more in the retinal periphery. So as I've discussed, this is the equator and this is the ora serrata. So usually the holes form closer to the periphery of the retina. So this is a hole here at the ora serrata, posterior to the ora serrata, and now we have a process through which the retinal detachment occurs. So as I mentioned that you'll have first of all formation of a retinal break, as you can see here, and then we should have liquefied vitreous which will allow the fluid to move around and form eddy currents, and these eddy currents basically they find the edge of the retinal break and they are directed underneath this retinal break, that is between the neurosensory retina and the retinal pigment epithelium. And as this fluid is directed, it continuously dissects between these two layers, and the result is that you have separation of neurosensory retina and retinal pigment epithelium, leading to retinal detachment. So now if we form a break here, and if we look at this break and we assume that this is the ora serrata here, which is the anterior limit of the retina. So if we start having fluid which is traveling between the layers, we start having a retinal detachment. And now as we can anticipate that the fluid, if it is being if it is being traveling underneath the retinal layers in a manner that which is guided by the eddy currents, that there is a possibility that this will progress equally on all the sides. So we should have a concentric circle forming around this, and this is how the retinal detachment should progress. So normally this is how a retinal detachment will progress, and we will have continuous movement of fluid which will dissect the retina So one thing is very obvious, that the detachment should progress equally on all the sides. So understanding this factor, which we can call as radial dissection. Second issue is that the gravity has a role to play, and because most of the times we are all standing erect, so gravity is going to pull everything down. So again, going by the same example, rather a different example in a location of the brake, if you have a brake which is somewhere here, if you have a brake somewhere here, again at the ora, and if we apply the first rule that the fluid should dissect equally on all the sides, then we should have a detachment will progress like this. But keeping in mind that we also have gravity playing around, so again, if we and predict the effect of gravity, then we can also understand that the progression would be faster along the side which is aided by the gravity. And one thing to note here is that at the disc you cannot have a detachment, because at the disc is retina is anchored. So whenever you have a detachment which will passing through the disc or across the disc, it will simply curve around the disc and then it will progress. So as we can see that this detachment, if it progresses with time, it will appear like this. So here we can appreciate the progression in this meridian is less when compared to this meridian. And this is all about how these two factors will interplay in causing progression of detachment. And I'll end my talk here and let you understand that these two factors will keep on playing till you have a complete retinal detachment. So this is going to progress on both the sides, faster on this side, and ultimately you have a detachment which will progressively increase and cover whole of the retina. So in next video we'll talk about how this is going to predict the location of a break in case we find a retinal detachment which is subtotal. So looking at the contour and looking at these two phenomena which are occurring continuously, we can look back and predict the location of a break from where the retinal detachment started.